to the next talk. This is about fingerprinting, gait fingerprinting, and it's a bit linked to what Marcin has shown also earlier this morning, and he has also been involved. And there were some really late minute programming and discussions going on, and I'm very curious what you can show now.
Can you hear me?
Yes. Mm-hmm.
Okay. Hello all. My name is Aydin, and I'm studying electrical engineering at master level in TUM. And we took this course as both of us are interested in healthcare applications of technology. And first of all, I want to thank Martin for giving us the opportunity to attend this lecture, and Martin for guiding us through the project with Martin. And Gait is one of many physical traits of an individual that can be used for recognizing a person. But what makes our gait so important, and maybe even more important than other biometric data like our face, our fingerprint? And first argument against conventional biometrics is their lack of privateness. Actually, they are not private. Do you think that is your face really your password like all the mobile phone manufacturers say? No, it's not. It's your username. And even your fingerprint is not private anymore. Let's consider your mobile phone. The actual reader on your mobile phone is really small, so that they're only capturing a tiny fraction of your fingerprint. Because of that, you can generate synthetic fingerprints. And recent studies show that almost 77% of mobile phones can be unlocked by generating a master set of fingerprints using artificial intelligence. But your gait is private. Nobody can hack it. And consequently, a number of studies have established the potential of using gait information to distinguish between individuals. The timeline and taxonomy shown here indicate the use of gait recognition in three main application areas: gait analysis, gait forensics, and gait biometrics. And as you can see here, it has a really rich history. Aristotle, from the ancient Greek, was the first person to take note of human and animal gaits in his work on the gait of animals. And then Count Giovanni Borelli is considered to be the father of biomechanics. I'm not going into details, but as I said, it has a rich history. There are even some more important works not mentioned in this figure. And one of them is the forgotten thesis of Gilles de la Tourette. He tried to characterize the gait characteristic using ink printing. To sum up, the take-home message from this part is all these works, starting with Aristotle from the ancient Greek, provide the basis for forensic and biometric gait recognition because they show that gait is sufficiently stable for an individual and distinctive between individuals. And gait as a biometric mark began first with video-based analysis, and then by analysis of underfoot pressures. And a more recent addition is the use of accelerometer data from mobile devices such as smartphones. But most of the research done in this field is based on video-based methods. And here we see the three different sensory modalities for gait recognition. The modality we used is an accelerometer-based method. We used the Activate device, high-tech 3D accelerometer hidden in a belt buckle, placed near the center of body mass. And it's already used in clinical trials, especially to evaluate a change in the real-world walking speed in patients with multiple sclerosis. For programming, Julia language is used. It's high-performance, dynamically typed language, and there are lots of already implemented Actibat packages, actually, which made things easier for us. And now that's part of my peer.
We implemented the norm step algorithm. So first of all, what is norm step? So the norm step is the average signal of multiple steps normalized in time domain. And in order to extract all steps from the acceleration signals, we have to use the step analyzer algorithm, which was already implemented by the Actibel team. And this algorithm proceeds as follows. First of all, it determines the dominant frequency in overlapping blocks. Then it extracts step-like patterns. And after that, it removes all duplicated steps. And in the end, it makes judgments of steps and process them. All this is done by calling the step analyzer object and apply it to the acceleration data we received from the Actibel. And as an output, we have multiple steps with useful information like the occurrence of the step, so the time, the speed, duration, distance, which side, left or right, and so on. Now that we have all steps, we filter them even more and keep the steps which have a duration of in the interval of 0.3 seconds and 1 second. After that, we extract the acceleration samples between each step start and step end. And since the duration of each step is not the same for each step, we have to interpolate the acceleration data so that we get the same length of acceleration signals for all steps, so that in the end we can average between all steps for left and right foot to get the norm step. How the norm step looks like, Aydin, can you go? Yeah. So in this, we can see here two plots of the same person of Aydin and two plots also for me. We can see that the norm step is similar for the same person, but different when we compare my norm step to the norm step of Aydin. So the plot here shows the three acceleration directions, X, Y, and Z. Yeah, and we can see that it shows small difference between different people. Aydin? So in order to investigate the uniqueness of norm steps, we wanted to calculate the L2 distance between different norm steps, and also I computed the distance between two segments of my norm step and the distance between my norm step and other norm steps to see if the distance is small between norm steps of the same person, and if they are and if the distance is large between different people. And as we can see here, the first comparison for left and right foot is the comparison between two segments of my walking, and it shows that the distance is small. So it means like that the norm step corresponds to the same person. But for the other comparisons, we can see that the distance is higher, which shows that the norm steps came from different people. Where can you go? Here we compared the distance between 40 individuals between each others, and we can see in the plot that the distance between there are many individuals that are not the same, have a small distance, like the distance between norm steps of many individuals which are different have a small distance, which should not be the case. So this means that the L2 distance between curves does not really penalize the fluctuations of a curve. So given a norm step curve, it is possible that they are different, but the distance would be almost almost the zero, but they are different curves. Okay, Aydin. So as I said, we might have a curve that is fluctuating a lot, but it's close in the L2 distance to a flat curve, so long as their moving average are roughly similar. So to solve that, what can be done in the future is to add L2 distance on derivatives of the curves. Another future work would be also the possibility to understand the meaning of peaks of the norm steps. For example, like if we see a norm step, we can assign that peak, a certain peak to a certain movement of the body, or also if we can assign a certain peak to an illness, for example, a knee problem or something like that. Thanks for your attention, and feel free to ask any question.
Yeah, so thanks a lot for this piece of work, and well, we should also remind ourselves, well, this was all under a condition where, well, meetings between the students was mostly not possible. We could not meet, so all these things had to be shipped around with regular courier to make sure that you've got the equipment, etc. But at the end, well, everything worked together, and you came up with these results that are really, I think, promising. And I also maybe give a couple of comments about applications of these kind of things. So when we talk to the regulators, to the European Medical Agency and also the FDA, when they talk about acceptance of outcome measures, they have a concern that patients may hand over the device to someone else. For example, if it's a matter of, well, keeping up with a certain number of steps per day and so on, and they don't want to do this or other reasons. And so the regulators are interested, can you somehow show that this continuous recording actually was done always by the same patient? And that is something that could be done without somehow violating privacy issues. Yeah. But the other part is that it has to do with what Marcin was mentioning. This is our attempt to have privacy by design. And then it gets a different flavor. Yeah? Because in Japan, for example, they have a law that data from iris scan or fingerprint or DNA have the same level of protection needed like Gait information. Yeah? So what you've just seen in the movie has made it already in the law. Yeah? And so that would mean one has to make sure that if you do this on a larger scale in clinical studies, in international studies, that you somehow can make sure that these data can really be anonymized. And as Marcin mentioned, this could be a very demanding scientific question. Yeah? What does it really mean to anonymize a long-term high-resolution recording of human motion? Yeah? And that's also something that is a debate between, well, the big legal departments of pharma companies and GDPR offices to tackle this question. What happens if someone can link large-scale video information from people in the public with somehow large-scale extrometry data? So that's from that point of view, this is a really important contribution. Yeah. Okay, now any other comments at that stage? If yes, then someone would need to raise the hand. Yes, Klaus.
Yeah, I was just surprised a little bit because I can remember that slightly more than 10 years ago, there was a big hype going already on using gait information as a means to identify individuals, like a fingerprint, as it was also mentioned here. And I can remember being at a conference where this was like the plenary talk of investigation and work. And at that time, it already seemed as if we're getting there to establish at border control points, at border entry countries, when you change the borders, to use Gait instead of other scanning devices to check for identity. And I was just wondering this, I think it's quite more than, it must have been like 2007 or so. So it's more than 10 years ago.
Mm-hmm.
Has that, I was just wondering, did that stop and it's now revival, or did this go in different tunnels and got it lost somehow? I was just surprised.
Yeah. So one comment is there has been a paper or a series of papers, 2 papers actually. It was called an algorithm for discovery, and where a group of people tried to explain what kind of environment do you need to have and what kind of algorithm should you follow to make sure that some discoveries are possible. They came to the conclusion, well, you cannot force anyone to discover something, but on the other hand, you can shape the environment such that either you completely discourage people to invent something or discover something, or you could have an environment that encourages this. And so they have actually a couple of rules. One is interrelate with intelligent friends, which is a good idea always. That's what we're doing today. The other part is read, but not too much. Because if you read too much, then you get disencouraged. Yeah? And that's what I tell the students. So read a little bit, and then if you get excited, just move ahead. Yeah? And I also heard this gait fingerprinting has been around for 10, 15 years. But if you come to this specific, extremely important application actually of using this stuff in clinical trials, which is in our view, one of the most important strategic things for really improving human health, then this has not made it into this field as far as I know. Yeah? And it will also depend a lot on the sensor location. Yeah? So I would argue that a wrist-worn device that can be used or is used also for physical activity monitoring, even for gait analysis in the sense of counting steps, I would not be concerned at all about privacy issues because the data quality is really lousy. But when it comes to more intelligent sensor locations, like around the waistline or something, then it becomes actually more sensitive. Yeah, but we are not experts in all the different sensor locations and their view on privacy. Yeah, but in principle, you're completely right. Yeah?
I agree with the assessment to say read something, but not too much. But sometimes, of course, you always have to face this question. Some technology has been around 10 years or 15 years, 20 years ago, and that's old-fashioned or so. And it may still be worthwhile to reconsider old technology because the environment and maybe some of the fringe conditions for the technology has completely changed. Either something 10 or 15 years ago was not feasible because you didn't have the computing power, or it has been transcending it was developed in a completely different environment, meaning people had totally different applications in mind. So I think this is, well, I've been experiencing this in my field for many, many years to say, okay, people have been scratching their heads for compressing video. And the main motivation by like having like watches that you can use for visual communication. And there was like a dream about 20 years ago for low bit video coding. So it developed over the years from a 0 million business to a 0 billion business. But nowadays, all of a sudden, all this old stuff, if you could say, is reinvented and rediscovered, and we are using it while we're talking over those channels. And I think for Gait, it might be just the same thing. People have been starting out with different notions and different applications in mind, and it got stuck. And maybe it's worthwhile to reconsider some of the results from earlier days. Once you have been going your own steps, and then you reread, and then you will probably find stuff that might be.
No, I mean, thanks again for the hint. I mean, and we will definitely do this based on what we've seen so far, and knowing now that we can use the data warehouse we've built over the last 15 years based on always the same 3D 100 Hertz exometry data from thousands of patients. that we have collected with not with a specific question at hand, but they can be used for the kind of analysis we've just heard. Yeah? Okay. Any other comments or questions?
A small side remark. I'm not sure if you can hear me.
Yes. Yeah.
Okay, so I want to recommend to everybody who is interested in privacy and gate identification the classical story of Gilbert Keith Chesterton, The Queer Steps.
Okay, can you somehow post this in the chat, Christian?
I will try.
Okay. Because
I have never used the chat before.
Okay, but it's sometimes it's always the first time one has to do something, so it's a good starting point. And I just want to say, well, Christian's recommendations are almost always powerful. So and if it's not if you're somehow not able to put it in the chat, then we will distribute this comment later on.
I'm still trying.
Yeah, you should see
the chat, but
yeah.
I see the chat, but
Okay, so I think as we go along, Christian will manage to get this in the chat, I would guess.
Yes.
And okay, now are there any other, while Christian is typing, are there any other questions or comments? Because if not, I'd like to thank the students